Okay, so this is the next question that we need to solve by Lagrange's method of multipliers. So first, I'll just write in short, okay? So let f of x1, x2 equal to this. So this is basically our f of x1, x2. Then we let h1 is equal to this. We shift 16 to the other side, so it becomes minus 16. I think I'll write this one again. Let this be equal to 1, and then let h1 is equal to 4x1 plus 3x2 minus 16, and let h2 equal to 3x1 plus 5x2 is minus 15. We shift the 15 to the other side. Nice. Now that we have that out of the way, we just need to define a Lagrangian function. Our Lagrangian function will have x1, x2 as well as lambda 1 and lambda 2. Two constraints or two multipliers, one for each constraint. So we get f of x1, x2 minus lambda 1 h1 minus lambda 2 h2. Our function is 6x1 plus 8x2 minus x1 square minus x2 square minus lambda 1. Yeah, okay. Minus lambda 1 into 4x1 plus 3x2 minus 16 minus lambda 2 into 3x1 plus 5x2 minus 15. Now we just need to calculate four derivatives. Derivative with respect to x1, x2, lambda 1, lambda 2. That is for a Lagrangian function. Del L by del x1 equal to 0, del L by del x2 equal to 0, del L by del lambda 1 equal to 0, del L by del lambda 2 equal to 0. Basically. So now for the first one, with respect to x, we get 6 minus 2x1 minus 4 lambda 1 minus 3 lambda 2 equal to 0. That's the first equation. Our second equation is del L by del x2. So we are differentiating this thing with respect to x2. We get 8 minus 2x2 minus 3 lambda 1 plus 5 lambda 2 equal to 0. Woohoo! Nicer. Then we get our differentiation with respect to lambda 1, which is basically just a constraint written down. You could just write it directly. Equation 3. Then we have equation number 4 for that lambda 2. Yeah. Equation 4, for that we differentiate with respect to lambda 2. We get the constraint again. 3x1 plus 5x2 minus 15 equal to 0. That's equation 4. Now we must solve this simultaneously. 4 unknowns. In the first one we have x1 का coefficient as minus 2. No x2 is present, right? Wait, x1 is minus 2, no x2, so x2 का coefficient 0. Then lambda 1 and lambda 2 have coefficients minus 4 and minus 3 respectively. And lastly this 6, if we move to the other side, we get a minus 6. For the second equation, there is no x1, so x1 का coefficient is 0. x2, lambda 1, lambda 2, so their coefficients are in the order minus 2, minus 3, 5. Minus 2, minus 3 and 5 plus 5. Hey, yo, wait. This will be minus 5. Yeah, silly error, minus 5. Yeah. And then this 8, when we shift it on the other side, we'll get minus 8. Now for the third one, we have no lambda 1, lambda 2. So their coefficients would be 0. But those of x1 and x2 would be 4 and 3. Lambda 1, lambda 2 have coefficient 0, 0. And this minus 16, when it goes to the other side, becomes a positive 16. Now for the next one, we have x1 and x2, right? So x1 ka coefficient is 3, x2 ka was 5. There's no lambda 1, lambda 2, so 0, 0. And then lastly, this minus 15, when it goes on the other side, becomes a plus 15. Now in solving, we get x1 as 35 by 11, x2 as 12 by 11, lambda 1 as minus 2 and 2 by 121, and lambda 2 as 268 by 121. We are not concerned with these, so we just ignore that because there's no use for them. They're only used to find x1 and x2 ka values. Other than that, they serve no purpose now, so we can forget about them. We only need x1 and x2 now. This is our stationary point. Stationary point. Now we just need to check whether at this point a function is a minima or a maxima. We have two variables, x1, x2, and two constraints. If you remember, the last time we had two variables and two constraints. Number of variables is equal to number of constraints. We directly calculated our Hessian matrix. So now our Hessian matrix here is basically del square f by del x1 square, del square f by del x2 square, and then we have del square f by first x2, then x1, then del square f derivative with respect to x1 first, then x2. Now we can just calculate this from the previous page. Our function is this, no? So now if we differentiate this with respect to x1 twice, x1 square, we get minus 2, and if we do the same with respect to x2 twice, we again get a minus 2, if you see. And if we differentiate each of them, once with respect to, for example, x1, and then with respect to x2, when we differentiate with respect to x1 then x2, we get a 0. And similarly, if we do the reverse, if we differentiate with respect to x2 first and then x1, then also we get a 0. If you like, you can cross check that later. So our diagonal elements are minus 2 and minus 2, minus 2, minus 2, 0, 0. Now whenever we have such a matrix, we only need to check our principal minors, d1, d2, d3. Over here, our maximum matrix ka size is 2 cross 2. No, so we stop after this. Otherwise, we would keep on going. Now, after calculating our principal minors, okay, this is a 1 cross 1, 1, and this is a 2 cross 2, 1. If both of them are positive, 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 then our point is a minima, okay. However, if the first one is negative and the second one is positive, then we'll have a maxima. This is for the condition when number of variables is equal to our number of constraints, okay. Only then it's valid. So now let's calculate our d1 and d2 ka values and see. So our d1 is basically just determinant of minus 2. This is not modulus, this is determinant. So we'll just get minus 2 returned, okay. Some people just get rid of the minus sign. So that's also there. Then for the second one, we have a 2 cross 2 determinant, which will give us a positive 4. As you can see, we did not get this one, we got this one. And alternating sign, negative, positive, negative, positive. Since we got an alternating sign, that means this point, that is, I guess it was 35 upon 11, 12, 11. Let me have a look. Yeah, that's the point. Is a point of maxima, a stationary point. Woohoo! Nice, no? Now we can just substitute this value in a function and get the maximum value of it. (35 by 11), 6 plus 8 into 12 by 11 minus 35 by 11 whole squared minus 12 by 11 whole squared gives us 1997 by 121. 1997 by 121, which when converted to a fraction becomes 16.5041 respectively.